Hi everyone, and welcome to my talk about a next-gen cloud platform using Open Compute Platform and Kubernetes. My name is Dinesh Madrekar, and I am Director of Innovation at Civo. I've been in the shared hosting industry for 15 years now, working from first-line support through to third-line support. I've been a developer, a systems architect, recently also getting involved in the DevOps side of the industry as well. Over the past 2 years, I've been working for Civo, who are a cloud-native public cloud provider, and we're focused on offering Kubernetes services to end users around the world. So we've got 3 regions that we've launched in the past 10 months, in the USA, in the United Kingdom and Germany. And this talk today is going to talk about our experience of developing the initial regions, getting the USA region out, and then some of the things that we've learned along the way. For Civo, over the next year, we're looking to add more racks in our existing 3 regions and hopefully looking to get at least 4 more geographic regions launched. So public clouds have some of the challenges that most other industries have as well, but kind of felt to a different level. So I've put cost on here, which everyone faces, but with our end users paying by the hour, it's really important that our costs from the hardware through to the colo space is kept as minimal as possible. We're also expected to have hardware on demand, with users kind of being able to spin up and down as quickly as they like. That means that we need to get new racks into existing regions really quickly, but also from a hardware failure point of view, if a server goes down or a switch goes down, we need to make sure we can rapidly replace that and get our capabilities back up to where it should be. We're also deploying around the world, and we have this ethos at Civo where we're going for everything being fully remotely managed. This means that we don't want to send engineers to every data center and have them kind of sitting around waiting for something to go wrong. So we've built our platform on OCP to kind of address the challenges that we've seen. On the right here, you can see one of our fully deployed racks, and these are some of the things that we find that have really helped us deploy quickly. So the standardization of all of the kit has been really useful. It kind of allows us to treat everything as cattle, not pets. This means that if a server breaks, we can just rip it out and replace it and not have to worry about anything specific on the server itself. The certifications that OCP provide from a vendor point of view as well as from a data center point of view means that our engineers can focus on the software stack and delivering services to end users rather than necessarily worrying about the exact details of what racks to use, what servers to use, and whether or not a new firmware is going to break things. The deployments are also really cost effective. Because everything is so interchangeable and we can ship things fully populated, we can keep those costs really low. And one of the other nice things as well is all of the rack designs are plug and play. The rack that you see on the right, we shipped to the data center fully populated like that in a box, and all the data center had to do was take it out of the crate, roll it into the rack, connect up the in-band and out-of-band networking, and power it on. Everything else was ready to go. So one of the other technologies that we used in our stack is Kubernetes. So for those of you who don't know, Kubernetes has become almost the de facto standard for managing workload at scale. So we see this in kind of the web app space, where traditionally you'd be hosting things like WordPress on a set of compute servers or IaaS instances. People are now moving to Kubernetes to orchestrate that and allow for rapid failure and rapid deployment and rapid recovery. We've taken this to our cloud hosting platform where we deploy Kubernetes to all of the servers, and then we use various Kubernetes sort of offerings and technologies to manage all of the workload. So there's a kind of similar organization to the OCP project in the Kubernetes world, which is the CNCF, or the Cloud Native Computing Foundation. They've got a lot of similar beliefs and ethos to the OCP of making things open source and giving back to the community. And outlined here are some of the projects that are part of the CNCF that we're using in our stack. So KubeVirt quickly is a sort of virtualization layer. It uses libvirt under the hood in QEMU to deploy virtual machines. K3s is a stripped down version of Kubernetes that allows us to really rapidly deploy Kubernetes clusters to our customers. So within about 90 seconds, you can get a cluster up and running. OpenEBS is a storage provider that we use under the hood, and we also use a thing called Operator Framework to orchestrate everything. So whereas traditionally you might have an engineer clicking buttons or going through GUIs to spin up a cluster or spin up a compute server or configure a network, Operator Framework allows us to programmatically do that and use a pattern called eventual consistency to ensure that things reach a desired state. So what we'd say is, please give me a compute instance with some networking configuration, and the various operators we have will ensure that within about 2 minutes the desired state is reached. And also if there's a deviation from that, so for example if a hypervisor goes offline and a compute instance for a customer goes offline, eventual consistency through the operator framework will mean that that VM is configured to provision on another server, spin up, and then it will keep the tenant up and running. So the timeline that we had for this project is pretty tight if you kind of think about it. So we actually started talking about the project in spring of last year. This was sort of the initial considerations of where we were currently at Civo and where we wanted to go, evaluating some of the technology that was out there and kind of picking a direction. Over the summer of 2020, we did the design, build and validate stages of the project. So this was a lot of POC work, testing out things, kind of failing rapidly and getting to a design that we think would work quite quickly. During this time also we had to order all of the hardware for our first region in New York. I'll kind of go over through some of the challenges with deploying a region, but we had to do that early in the summer to give enough lead time to get things running, which means that the first time any of our team had any production kit to play with was in December, with the actual production kit in a remote data center. So that didn't go completely to plan, which again I'll kind of cover one of the interesting stories during that. But in February of this year we launched our New York region. We quickly followed that in March with our London region, and we've recently in September launched our Frankfurt region, and all of the racks were all the same. We had a few changes to the specs but nothing huge, and it validated a lot of our things over this year of our design decisions. So during the design, build and validate stage of the project, we had 2 stacks of hardware. We had some POC hardware that we had for about a year before that actually, and our engineers were just tinkering around and playing with. Once we had a design, we got some staging hardware deployed in a half-rack OCP rack, which mirrored the production infrastructure we thought we would go with, but with some reduced RAM, reduced CPU specs, and reduced disk space. But other than that, it had all of the resiliency in place that we could start validating things like if we lost a switch or we lost a network path, what would happen and how could we ensure that the platform stayed up during that time. During this time, we also had a lot of work on the network design. This was both on the physical layer. We ended up with a spine leaf architecture, but also on the kind of overlay network as well. So how we ensured customer isolation across the various networks and how we allowed for failover as well. With us working towards a completely remote deployment, the zero-touch provisioning side of our infrastructure was really, really important. So we treated our staging rack as if it was completely remote, even though in reality it was in the room next door. We encouraged our engineers to not treat it like that. So anytime that they had to install an OS or do a sort of replacement or anything, we treated it as if we were making requests out to a remote data center to do that, just to kind of validate and help us work out whether we could do this fully remote or whether our data center choices had to be influenced so that we had staff nearby. With the remote first idea, we had some real challenges with the BMCs on our initial servers. So the Winterfell servers that we were initially playing with had a onboard 1 gig network for the BMC and management. This was kind of complicated from a hardware design because it meant that we would need an extra switch in the rack, and also from a resiliency point of view, if we ever lost that 1 gig switch, it would mean that we'd lose all management access to the servers. Also, we found that the BMCs on the Winterfell nodes were really buggy and difficult to work with. So if we ever sent a reboot command to one of these servers, they'd lock up for about 2 minutes. The BMCs, that is, they'd lock up for 2 minutes. By the time they came back online, you'd normally skipped over the BMC part. You'd normally skipped over the BIOS part of the boot, which meant that configuring and changing that was really, really difficult. It also meant when you wanted to do a reinstall and choose Pixie boot rather than on-disk boot, it was challenging, almost impossible to do so. So when we got the staging kit, we went with the next gen of the TIO Pass servers, and we went with the Mellanox NICs that had sideband management capabilities. So it was the upgraded motherboard, the BMC, and the move to the Mellanox NICs that really helped us out here. So the sideband management and the BMCs here meant that our networking design was a lot simpler. We didn't need that 1 gig management network, and the failover paths for data allowed us to also have failover for the BMC. Also, the upgraded firmware meant that whenever we rebooted a server, we didn't actually lose BMC console access at all. So we could easily go in and select the BIOS, or we could select Pixie, and it just made configuration a lot easier. I think it's important to remember here when you're designing things that it's not only the hardware specs that you're looking at, like the outright performance or throughput, but some of the management capabilities as well. So I think if we didn't have the TIO Pass servers, it would have made using OCP and progressing with the project a lot more difficult. So outlined here are some of the things that we needed to consider with that first rack that we got delivered. So on the build, we actually partnered with Vespertech, who are a OCP solutions provider, and they did all of the purchasing, managed the delivery of the kit into the UK, actually building the rack, cabling it up, and doing the initial validation. Again, because of our tight timelines, this was really, really important. They also had a lot of experience with the shipping and the import of kit from the UK into the US, so they were able to handle all of that as well. So they were the ones that arranged the plane, the delivery at the remote site, also walked us through all of the customs and import from the UK into the US. One of the other things that we needed to consider was the connectivity. So from us saying, yes, let's go and ship the rack to the US, it would probably only take about a week from that point to getting the rack on site. However, connectivity kind of takes a lot longer than that, and we had one provider take 3 months from us signing the order to having that provision in the data center. So just remember that some of these things take longer than the other, and you can't take the shortest sort of item and base all of your timelines off that. The other thing we needed to consider, again, with us not having staff on site, is the final mile delivery, the unracking of the, removing the servers from the van, from the lorry, getting it into the data center, and then we had to work quite closely with the data center partner as well to actually unbox the rack, do the disposal of the shipping containers, and roll it into the right place in the data center and power it on. So we had a lot of conversations with INAP, our first data center provider, about how they would support us during that, and they were really, really helpful with that. Also, INAP had previous experience with OCP kit as well, so when the racks turned up, they knew what to expect and it wasn't a surprise. Also, when we talked about some of the floor loadings, because it's not only the floor loading at the final site where the rack is going to sit, but also all of the floor loadings in between the delivery area and that final destination as well. And other things you didn't consider are like lift heights as well, so making sure that the racks can fit into lifts. So we had some data center providers that we were talking to that just didn't have the infrastructure set up to handle these large and heavy OCP kit. So unfortunately, when we got the kit into New York and powered it on, it was semi-successful. So the networking devices all came online. If I remember, it was the Christmas Eve, I think we finally got the kit powered on. So all of the engineers were gathered around a Zoom call with the data center, lots of cheers, saw the network come up. We had our network engineers quickly log in, prove that we had out-of-band access, we could get to all of the switches, to all of the routers, and everyone kind of signed off of like, great, everything's fine, let's go enjoy Christmas. Engineers come back after Christmas and start working with the kit and realize actually that the servers haven't come online at all. So during this whole time, we just didn't check the servers. We were speaking to Vespa and they said, oh no, definitely the servers came online before they shipped to the US. We had engineers that were doing some initial validation and said, yep, definitely got into the servers before it shipped, but it was no luck when it was in the States. So going backwards and forwards with the power vendors and with Vespa themselves, and actually going through the documentation ourselves for some of this stuff, we found the diagrams that you can see here. So on the right, you can see the rear of one of the power shelves. So this is taking three-phase power in and distributing it out to the 12-volt rails. And there is this RJ45 control socket on there. And we found this PS on shelf low, which is what that symbol is, which is power supplies on to the shelves needs to be provided a low signal to power on. We didn't know this. This was on the US spec versions of the power supplies only, rather than on the UK ones. So kind of give you an idea of what that looks like on the back of the rack. You can see outlined here in red is what that socket looked like, and it's conspicuously empty. So what we think is that this has been designed to go to some other management system so that you can remotely tell the power shelf to turn on or not. I guess if you're in data centers that had power problems or you wanted to do a remote power on of kit, you could manage it through here. However, we didn't have that. So we kind of came up with two solutions. The first was a bodge, which is what you can see on the left-hand side. So that is a Cat5 cable that we found lying around. I say we, the data center found lying around. And they have stripped off the brown and white connections and just connected them together, kind of twisted the cables together. We then went back and plugged it into this socket, and great news, all of the compute servers came online. However, we did have this very dodgy looking cable on two of the power shelves in our production kit, which wasn't ideal. So we came up with the solution on the right, which is just taking a Cat5 boot, an Ethernet boot, and putting a loop of cable between the pins for the PS on shelf and ground. So if we come back to this diagram here, you can see that just the two pins 1 and 2, or 7 and 8, depending on which way you're looking at it, you can just tie them together, and that will provide the low signal and connect or allow power to come on. So plugging this into a switch, this is what it looks like, and this is currently live in New York and keeping all of our shelves online. So once we had that online and we got into the servers and started sort of validating the config, we started seeing some servers come online with failures either during transit or during build. Because of the tight timelines we were working to, we weren't able to fully validate that all of the servers came online before shipping. We kind of just did some spot checks and had to get it out of the door. So on the left hand side here, you can see on one of the motherboards the connections for power to the SATA drives. The sort of module was just completely screwed over. All of the connections were wrong. Either it was burnt out or it wasn't plugged in correctly, and yeah, it were just problems, and we didn't have NVMe drives on that server. So what we were able to do with this is just get this entire server shipped back to the UK. Well, actually what we did was we got a new one built from the UK, shipped it out to the US, had the data center replace the server, and put this broken one back into the box that the new one came in and ship it back to the UK. We're then able to reuse the bits of hardware in future regions apart from the main motherboard. But that got this server up and online. The other thing we saw was just again, either during transit or during build, some of the SSDs, NVMEs, weren't seated correctly in the PCIe slots. So we were able to work with the data center just to unplug and reseat the NVMEs, and that brought some other servers back online. After about a month of running the region, we kind of found that we'd underspec'd the amount of RAM in all of the compute servers. So we had kind of like a day two operation of having to go through and physically add more RAM to every single one of the compute servers. So I think there are 35, 36 servers in the rack, and we were able to work with the data center to get this all done within a day. So with there only being 2 network connections on each of the servers, it was very easy to coordinate with the data center with the ILO lights of saying, yep, let's take this server out. With all of the tool list design as well, they were able to quickly slot the case off the top, plug in the new RAM, slot it back in, and it was actually only a day to do all of the servers and get them all replaced. And this is while we were live as well. So we were evacuating compute nodes, making sure workload was all working, and then bringing the compute node back online. I just want to highlight that the OCP certifications that are out there are really, really helpful for companies like us that are looking to deploy OCP kit around the world. So from the solution provider point of view, we worked with Vespertech, as I said, and they were able to guide us through the purchasing and the speccing of kit. So our engineers were able to talk to them directly, and they were able to advise, yes, this would work, or this spec wouldn't work. And actually things like it would be more cost effective to use this amount of RAM in this configuration versus another one. And then they were able to handle all of the build for us as well. So that was, again, really, really useful. Then when we were working with data centers as well, it was really important that we found out that people had the Colo Solution Provider certification as well. It just meant that the engineers on site were able to understand the kit we were developing and deploying, but also they had all of the infrastructure in place to accept these high weight racks and the tall racks as well. Overall, we've been really impressed with the OCP kit over the past year, well, probably 2 years now. I think there is a myth almost in the industry that the OCP kit is for hyperscale deployments, when you're kind of deploying out either full pods at a time, like 10 racks, 20 racks, or full data centers at a time. However, it is very suitable for rack scale deployments, both in half scale racks to full scale racks as well. All of the OCP kit has been designed to allow rapid deployment, and we've definitely seen that not only with the initial deployment into a region, but also with general maintenance. And we're also really excited on the growth. As we add new racks to existing regions, all we're doing is cross-connecting and powering up to our first rack, and everything else is good to go. I kind of put this, expect the unexpected is probably something we hear a lot in the industry, but just want to highlight that it's both technically and operationally. So the power issue that we faced, probably more of a technical issue, but it was really nice having open standards that we ourselves could go in, start looking at the specifications for the power supplies. It meant that we're not reliant on vendors with closed architecture, and potentially we're in a month, 2 months process of backwards and forwards. Vendors are having to send engineers out to site, rather than us bringing up the specs and going, oh, hang on a minute, this looks like it could be our problem, and we were able to start getting a solution out quicker. Operationally as well, it's very difficult, it turns out, to ship kit around the world. Not really from a logistics point of view, but more from a tax process, a compliance point of view. Getting kit into Germany has taken us a long time, again, mainly because of the operating restrictions around working in Germany. We're also looking now to work into India, and we're just kind of seeing as well that the culture is different as well, and it's just more of a challenge, and it's taking longer to do things than we would normally expect going into the UK or the US, where we have a lot more experience. If you want to find out more about Civo, you can visit us there at civo.com. I also want to thank the OCP related partners that have really helped us along this journey. Vespa, our solutions provider, and the 3 data centers that we've got there, so it's MainCubes, INAP, and KO Data. They've all been really instrumental in getting us to where we are, so thank you to them. And that ends my talk. If you have any questions, you can feel free to reach out to me on Twitter or on LinkedIn. Also, the community Slack that we've got at Civo, all of our engineers, including myself, are on there, and we're always happy to answer questions.